I will do.
Now you have to only do intro and camera.
Yes.
Mic on.
हाँ. Hello students, welcome to IMS GATE Academy GATE previous year questions series of communication system subject. So in the last two sessions we have discussed regarding the GATE 2023 questions and GATE 2022 questions which are asked in the EC branch. Okay, we have discussed the variety of questions and those questions and concepts are very much helpful for EC and instrumentation branch. Similarly, in this particular session we are dedicating the session regarding the previous year GATE questions of 2021 which are asked in the EC branch. I have selected the good number of questions in this particular session we are going to discuss. So all of you are getting the concepts, idea, and you are getting the method of solving also. So all of you kindly share this video link with all of your friends. This session is also helpful for both the branches like EC branch and instrumentation branch. So kindly share quickly this video link with all of your friends. We are going to start the session soon, right? So I hope all of you are eagerly waiting for the session. So let us start. So this is the first question which is asked in GATE EC 2021 for 1 mark. So all of you read the question carefully and try to answer. So I will give the timer for every question. I will give some time. According to the question, I will give 2 minutes or 3 minutes or even 1 minute. According to the level of the question or difficulty of the question, I will give the time. So all of you give a try. So here first let us read the question. Consider a carrier signal which is amplitude modulated by a single tone sinusoidal message signal with a modulation index of 50%. They have given modulation index as 50%. If the carrier and one of the sidebands, are suppressed in the modulated signal, then the percentage of power saved they are asking. The percentage of power saved they are asking. Okay. And what is the answer you are getting? You have to round off after 1 decimal place. Okay. Right. So first of all, write down the modulation index given. They have given the modulation index as modulation index mu equal to 50%. So this percent you can write divide by 100. Percent. Cent is nothing but 100. So here 1 0 will get cancelled. 5 by 10 is nothing but 0.5. So the modulation index they have given 0.5. I hope all of you know that regarding AM signal, the amount of power that is required for transmitting AM signal is nothing but PC into 1 plus mu square by 2. PC into 1 plus mu square by 2. So multiply PC with both the terms. You are getting PC plus PC into mu square by 2. So here PC is the carrier power, whereas PC mu square by 2 is the total sideband power. So in the AM we are having 2 sidebands. One is lower sideband, another one is upper sideband. Together we can call it as total sideband, or you can say double sideband power, and then carrier power. Okay. So for the timing I am splitting this term into 2 terms. Okay. So we can write it as PC plus PC mu square by 4 plus PC mu square by 4. Whatever the term here you are having, I have made into half. Like that I have written 2 terms. Okay. So when you are adding these 2 terms, you will get this one. Okay. So that means this PC is nothing but carrier power. PC is nothing but carrier power. Whereas here you are having 2 terms. One term related to the, say for example this one I am assuming that the power of the upper sideband. Similarly, the power of lower sideband also same. Okay, both the sidebands will have the same power. You can assume this is like lower sideband power, this is the upper sideband power, no problem. Okay. So in the AM signal, you are having the carrier power and you are having both the sideband power you are having. Right. Now just read the question carefully. If the carrier and one of the sidebands are suppressed, that means, say for example, you are transmitting only lower sideband. Okay, so yes, you have suppressed the carrier power and you have suppressed the upper sideband. Okay, so these two if you have suppressed, that means this much amount of power you have saved. Yes or no? In order to transmit this particular signal, you require only this much power, right? In order to transmit either lower sideband or upper sideband, you require this much power. But when you are transmitting AM signal, you require the total power is this much, right? So now the question is the percentage of power saved. They are asking. So this much power you have saved when compared to the total power. So now you can calculate the percentage of power saving. So they are asking percentage of power saved. Percentage of power saved is equal to PC plus PC into mu square by 4 divided by this total power, PC into 1 plus mu square by 2. PC into 1 plus mu square by 2. So in the numerator you can take PC as common. That time you will get 1 plus mu square divided by 4 divided by PC into 1 plus mu square by 2. So here PC we can cancel. So just do the LCM. So here in the numerator you will be having 4 plus mu square divided by 4, and here you will get 2 plus mu square. So 2 2 times. So that means you are going to get 4 plus mu square divided by 2 into 2 plus mu square. 2 plus mu square, right? Here they have given mu value as 0.5. So from here you can calculate mu square is nothing but 0.25. 0.5 whole square is nothing but 0.25, right? So you can directly substitute here 4 plus 0.25 divided by 2 into 2 plus 0.25. So from here you will get 4.25 divided by 2 into 2.25. So all of you give a try. You can use your mobile or you can use calculator. Try to do the simplification of this one and tell me what is the answer you are going to get. Yes, I hope all of you are getting this answer, right? 0.944. 0.944 you are going to get. So 0.944 you are getting the normal value, but they are asking represent the value in terms of percentage. Just like here, say for example, modulation index you are having 0.5, that value they have represented in terms of percentage like this. 50% is nothing but 0.5. In the similar way, here 0.944 we can write it as 94.4 percentage. See, percentage you can write it as divided by 100. So 94.4 divided by 100 is nothing but 0.944. So whenever they are asking in terms of percentage, after doing the calculation, if you are getting the real number, that number convert into percentage. That's all. Okay. So the answer for this question is 94.4. 94.4. I hope it is clear for everyone. Now I will show the next question. So all of you give a try. This is a 2-mark question. So in this question, they have given that you are having the sinusoidal message signal. Sinusoidal message signal. So regarding that, they have given the corresponding root mean square value. They have given RMS value, root mean square, as 4 volts. As 4 volts. And the frequency of the message signal they have given 1 kilohertz. 1 kilohertz. So this particular message signal they have given as one of the input for the phase modulator signal. Phase modulator circuit, they have given this particular message signal, sinusoidal message signal, and this phase modulator is having a phase deviation constant as 2 radian per volt, 2 radian per volt, and they have mentioned the carrier signal C of t equal to 2 cos 2 pi into 10 power 60. Now the question is the maximum instantaneous frequency, the maximum instantaneous frequency of the phase modulated signal they are asking, and whatever the answer you are getting, you have to round off your answer to the 1 decimal place, and here most interesting thing, the answer they are expecting in the order of hertz, in the order of hertz. Okay, so first of all, write down the given data. From that we can calculate one parameter, and then whatever they are asking we can calculate that exactly, okay, after few iterations. Okay, right. So first of all, you can write down regarding the message signal, they have given the RMS value, root mean square they have given, RMS value they have given of the message signal they have given as 4 volt. So in general, you know that VRMS is nothing but VRMS equal to Vm by root 2. So in general, for the message signal we will consider the peak amplitude as AM, so accordingly AM by root 2. Here VRMS is 4, so that means 4 equal to AM by root 2. So from here you are going to get AM as 4 into root 2 volts, 4 into root 2 volts. Okay, and here regarding the sinusoidal message signal, they have mentioned the frequency as 1 kilohertz. So that means FM equal to 1 kilohertz. So you know the peak amplitude of the message signal, you know the frequency of the message signal, and here they have mentioned it is a sinusoidal message signal. So that means now you can write the representation for the message signal. So which is nothing but m of t equal to am sin 2 pi fmt, am sin 2 pi fm into t. So here am is nothing but 4 root 2, am is nothing but 4 root 2 sin 2 pi into fm is nothing but 1k, 1k we can write as 1000, or you can write 10 power 3, your wish. Okay, 2 pi into 1000 t, you can write 10 power 3 or 1000, your wish, right. So this is your message signal, this is your message signal. Okay, right, 4 root 2 sin 2 pi into 1000 t. And here they have mentioned the phase deviation constant, 2 radian per volt. Phase deviation constant they have given, that is nothing but Kp, which is nothing but 2 radian per volt, 2 radian per volt. And they have given the carrier signal C of t equal to carrier signal C of t equal to 2 cos 2 pi into 10 power 60, 2 cos 2 pi into 10 power 60. So just like your message signal am sin 2 pi fmt, similarly here you are having AC cos 2 pi fct, AC cos 2 pi fct. So that means here the peak amplitude of the carrier is 2, and here the frequency of the carrier signal is 10 power 6 Hz, 10 power 6 Hz. Okay, so up to here whatever they have given in the question, that data we have written, right. Now what we have to calculate? We have to calculate the instantaneous frequency, the maximum instantaneous frequency we have to calculate. So first of all, write the instantaneous frequency formula. I hope all of you are familiar regarding the instantaneous frequency. Fi equal to fc plus 1 by 2 pi into d phi by dt, 1 by 2 pi into d phi by dt. So this is the formula for instantaneous frequency. Here the frequency of the angle wave is varying, okay, with respect to the carrier frequency. So from the carrier frequency you are going to get, at some places you will get, when compared to carrier frequency you are going to get higher, in some times you will get, when compared to carrier frequency you are going to get minimum, like that, right. Fine. So here phi is nothing but Kp into m of t. So Fc I am substituting 10 power 6 plus 1 by 2 pi as it is. So here phi is nothing but Kp into m of t. Kp into m of t. Kp into m of t. Right. So here 10 power 6 you can copy as it is. Then here Kp is a constant, we can keep outside the derivative, into d by dt of message signal. Message signal is nothing but am sin 2 pi f mt. From there we got this expression, right? So this expression now you can substitute 4 root 2 sin 2 pi into 1000 t. 2 pi into 1000 t. Okay, 4 root 2 into sin 2 pi into 1000 t. So just perform the differentiation here. Here Kp value is 2 divided by 2 pi. Here 4 root 2 is the constant, we can keep outside the derivative. Okay, derivative of sine term, you are going to get cos term. Derivative of sine is nothing but cos, and derivative of sine term is cos, and derivative of this particular term is nothing but 2 pi into 1000. 2 pi into 1000. 2 pi into 1000. Right. Now here 2 will get cancelled. 2 will get cancelled. So you are going to get 10 power 6 plus 4 2s are 8 root 2. 4 2s are 8 root 2. Then pi will get cancelled. Pi will get cancelled. 4 into 2 is 8. 8 root 2 into 1000. Into 1000. Then cos 2 pi into 1000 t. Cos 2 pi into 1000 t. Now you got this is the instantaneous frequency. Instantaneous frequency. What they are asking in the question? They are asking the maximum instantaneous frequency. Maximum instantaneous frequency. Now when you observe here, in this entire equation 10 power 6 is constant. We are adding that constant with this particular term. Okay. So here also this term is constant. This term is constant. This term is constant. But here you are having what? Cos signal. So whenever you are having cos signal, what is the minimum value and what is the maximum value for cos? For cos signal, what is the minimum and what is the maximum value? For cos signal, the minimum value is -1 and the maximum value is +1, right? So when you consider cos value as -1, so this overall term, overall value will get minimum. And when you consider cos term value, maximum value as +1, that time overall this frequency you are going to get maximum. So that means regarding the instantaneous frequency, if you want to get maximum, so here cos value should consider maximum. That is nothing but +1. Now I am writing the instantaneous frequency maximum. Instantaneous frequency maximum. So which is nothing but 10 power 6, which is nothing but 10 power 6 plus 8 root 2 into 1000. 8 root 2 into 1000 into cos value I have considered +1. Then from here you are going to get maximum, right? So all of you give a try. What is the simplified value you are going to get for this question? For this question, after doing the simplification, you will get like this: 10, 11, 313.709. 0.709. So you are going to get actual answer like this for this question. Okay. If they mention that whatever the value you are going to get, that value you can enter, then this is the answer. That means after the decimal place, you are considering the 3 digits. Okay. Same answer if you are round off to the 2 decimal places. If they ask to round off to the 2 decimal places, that time you have to observe the third digit. This third digit value you are having greater than or equal to 5. So whenever that condition satisfy, you can add 1 to the lower one, right? You can add 1 to the previous digit. So here 0 plus 1 is nothing but 1. So if they ask that you have to mention the answer round by considering round off to the 2 decimal places, then this is the answer. Similarly, if they are asking with respect to 1 decimal place, okay, after the decimal point, if they are asking only for 1 decimal place, that time the answer will be here in this question 7, because here the second digit value is less than 5, less than or equal to 5, right? So that means here you no need to add any one. Suppose if this digit value is greater than or equal to 5, that time you can add 1 here, right? So in the given question they asked that you have to round off your answer to the 1 decimal place. Okay, you have to round off to the 1 decimal place. So the final answer for this question is this one, 1011313.7. Here the units are hedges. Okay, so I hope it is clear for everyone. Next question. This is simple question and direct question related to the superheated and receiver. So all of you give a try. Yeah, in this question they have given the weightage of this question is 2 marks, but this is the dead easy question. You can easily score 2 marks for this question. This is a direct question. Here they have mentioned regarding the superheated and receiver. Consider a superheated and receiver tuned to 600 kHz. If the local oscillator feeds a 1000 kHz signal to the mixer, they are asking the corresponding image frequency. Image frequency in the order of kilohertz. In the order of kilohertz. So first of all, here you are having 600 kHz, so that is nothing but your signal, incoming signal frequency. So Fs equal to 600 kHz, and the local oscillator frequency they have mentioned 1000 kHz. Local oscillator frequency is 1000 kHz. When you take the difference of these two, that is nothing but intermediate frequency. Intermediate frequency, you will get FL minus Fs. So here FL is 1000 kHz minus Fs is 600 kHz. Okay, so 1000 minus 600, that is nothing but 400 kHz. 400 kHz. Now they are asking image frequency. Image signal frequency I am labeling as FSI, which is nothing but the incoming signal frequency plus twice that of intermediate frequency. So incoming signal frequency is 600 kHz plus 2 times intermediate frequency is 400K. 400K. So 2 into 400, that is nothing but 800. 800 plus 600, that is nothing but 1400. 1400 kHz. So since in this question they are asking in the order of kHz, right? So that is the reason. In some question they will ask in the order of Hz, sometimes they will ask in the order of kHz. So especially when you are having NIT questions, so just take care about the units. Just take care about the units. So according to the units, after solving any question, what is the answer you are getting before you are entering your answer from the keyboard in the GATE exam, right? So just look at the units. According to the units, you can mention the answer. So here the answer for this question is 1400. Answer for this question is 1400. Okay, right. I hope it is clear for everyone. So now let us move on to the next question. So all of you give a try. This is a question based on random variable. Yeah. In this question, they have mentioned that you are having two random variables x and y. Both are continuous. Both are continuous random variables. And among x and y, they have mentioned the relation like this. Y equal to 2x plus 3. y equal to x plus 3. And here they have mentioned sigma x square and sigma y square are the variance of x and variance of y. Okay, variance of x is sigma x square and variance of y is sigma y square. And here they have given 4 choices regarding the variance of y and variance of x. In terms of variance of x and y, they have given the relations. Okay, so whichever relation is correct, that you have to choose. This is the MCQ question. Obviously one option will be correct, right? So first of all, let us calculate variance of y. Variance of y. If you are having y is one random variable, so for that how we can calculate the variance? Okay, that let us start now. So I hope all of you know the standard formula regarding variance of any random variable. Okay, if you are considering variance of random variable is y, so this one we can write it as expectation of here random variable is y, so that random variable minus the mean of that random variable whole square. Okay, expectation of y minus y bar whole square. So here in this particular equation, we know regarding y, but we don't know y bar. So first let us calculate y bar. Okay, so in this equation, in this question, they have given regarding y as 2x plus 3. So y equal to 2x plus 3. Now let us calculate expectation of y. That is nothing but y bar. Expectation of y is nothing but y bar. Okay, so in place of y you are having 2x plus 3. Now we can perform expectation operator by performing individually. We can perform expectation operation and then we can perform the linear algebraic addition. Okay, so expectation operator is the linear operator. Okay, we can perform expectation operation on individual terms first and then we can perform the algebraic sum. So I am splitting like this: expectation of 2x plus expectation of 3. So here you are having 2 is the constant, we can keep outside. So 2 into expectation of x plus expectation of constant is same, constant only. Okay, so you are getting 2 into expectation of x plus 3. So expectation of x you can write as x bar, here 3. Okay, right. So you got y bar as 2 times x bar plus 3. Now you can substitute y and you can substitute y bar. From there you can calculate variance of y. So variance of y. So suppose this one I am labeling as equation 1. So equation 1 we can write it as variance of y is equal to expectation of y is nothing but 2x plus 3 minus y bar is nothing but 2 into x bar plus 3, and then this overall term you are having square. Now expectation of 2x, then here plus 3 is there, minus of plus, that is nothing but minus. So plus 3 and minus 3 will get cancelled. So you are getting 2x minus 2 into x bar whole square. So from these two you can take 2 as common. Expectation of 2 square into x minus x bar whole square. From these two we can take 2 as common and then you are having power 2. 2 square into x minus x bar whole square. So just like here 2 is the constant, we kept outside the expectation. Similarly here 2 square is the constant, that constant we can keep outside the expectation operator. 2 square is nothing but 4 into expectation of x minus x bar whole square. Now just carefully observe. Here we have written expectation of y minus y bar whole square, which is nothing but variance of y. Similarly, expectation of x minus x bar whole square, we can write this one as variance of x. Yes or no? Variance of x. So that means we got variance of y is equal to 4 times variance of x. In the question they have mentioned variance in terms of like sigma symbol. Variance, they have used the notation sigma square, right? Sigma x square is the variance of x, sigma y square is the variance of y. So that notation let us use. So sigma y square is equal to 4 times sigma x square. Yes or no? Sigma y square is equal to 4 times sigma x square. So that means option B is the correct answer. Option B is the correct answer. 4 times sigma x square. Okay, it is a simple question. For understanding purpose, I have discussed this question in the conventional approach. Okay, but if you know the properties of variance, you no need to write this many steps also. Without using pen and paper, directly you can choose option B as the correct answer for this question, right? So regarding the second method, shortcut method, now I am going to discuss. Whatever the methods so far we have discussed, that is the method 1. Now I am giving the second method. With the help of that, you can answer this question without using pen and paper. Method 2. So here in this question, they have given the random variable y as 2x plus 3. Random variable y as 2x plus 3. Now this particular equation, if you observe, it is in the form like this. Y equal to ax plus b, where x is the random variable and a and b are the constants. Where a and b are the constants. Okay, so variance of y is equal to variance of ax plus b. Variance of ax plus b. In place of y, you are having ax plus b, you can substitute. Just like expectation operator, we have performed the linear sum in the similar way. In the similar way, here also variance operator we can split like that. Variance of ax plus variance of b. Variance of b. Because in this first term, only you are having the random variable, whereas the second term you are having simply constant. Okay, that is the reason we can do like this. Okay, right. So here you are having variance of ax. So regarding this, if you know the property, variance of ax is nothing but whatever the constant here you are having, you will get. See, in the expectation operation, that time, whatever the constant you are having, we kept outside. Okay, but in the variance term, in the variance function, you are having expectation operator, but inside the expectation operator, we are going to perform for the square term, for the square term, right? So here whatever the constant you are having, that will become constant square. So that means a square into variance of x, a square into variance of x. Okay, regarding variance of constant, see, earlier we have mentioned expectation of constant is constant, right? So here variance of constant you will get 0. Variance of constant you will get 0. If you know these two properties, variance of constant is 0, variance of a times x is nothing but a square variance of x. If you know these two properties, you can answer this question without using pen and paper, right? So finally you are going to get a square into variance of x. A square into variance of x. Okay. So in this question you are having variance of y is nothing but 2x plus 3. Variance of y, that is variance of 2x plus 3. So here, according to this particular notation, a is nothing but 2. A is nothing but 2. So that means 2 square into variance of x. 2 square into variance of x. 2 square is nothing but 4. 4 times variance of x. So according to the given notations, we can write this equation as sigma y square equal to 4 times sigma x square. Okay, if you know the properties of variance without using pen and paper, directly you can choose option B. Right. So the next question, all of you give a try. Yeah, in this question they have given the autocorrelation function, the waveform they have given. So here x-axis you are having the tau and y-axis is the autocorrelation function of the random variable or random process x. Okay, so here they have mentioned x of t is the wide sense stationary random process. So for that random process you are having the corresponding autocorrelation function, that is Rx of tau. So at tau equal to 0, we are having its value as 2. At tau equal to 2 you are having autocorrelation function as 0. At tau equal to -2 also 0. After that, other than this interval, remaining entire tau values you are having autocorrelation function as 0. So they have given autocorrelation function diagram. Now the question is they are asking the average power of the random process x of t. Average power of the random process x of t. So whenever you are supposed to calculate average power of x of t, which is nothing but expectation of x square, So if you know x of t, you could have substituted here. After that we could have proceeded. Okay, just like in the earlier question we got variance formula in terms of expectation, and regarding y we are having, and similarly we calculated y bar and we substituted, and accordingly we have done the simplification, right? In a similar way, if you are having x of t, we could have substituted and we could have done the simplification. But surprisingly, in this question they haven't given anything regarding x of t equation, but they have given the clue. What is the clue? They have given the autocorrelation function. So since they have given autocorrelation function, first of all write the autocorrelation function equation. I hope all of you know the autocorrelation function equation. Rx of tau is equal to expectation of x of t into x of t plus tau. Expectation of x of t into x of t plus tau is nothing but Rx of tau. Now here if you observe, you are having x square of t, but there you are having x of t into x of t plus tau. So that means you are getting like multiplication of two terms, right? So for the timing I am writing this term like this. Expectation of x square of t you are having, that one I am writing it as expectation of x of t into x of t. Now you can compare this equation with that. X of t, the first term is exactly matching, but the second term you are having simply x of t, but here you are having x of t plus tau. So that means when you consider tau equal 0, then this equation is matching to this equation. Yes or no? So just make a note, if tau equal to 0, then Rx of 0 is equal to expectation of x of t into x of t. Okay, I hope you are getting the clarity. Now you are having expectation of x of t into x of t, so this you can write it as Rx of 0. So that means autocorrelation function, in the autocorrelation function when you consider tau equal 0, that time whatever the autocorrelation function value you are going to get, that is nothing but average power of x of t. Okay, so in this particular autocorrelation function at tau equal to 0, we are having autocorrelation function value as 2, right? So that means finally the answer for this question is 2. Since they have mentioned it is average power, so the units will be watts. Okay, sometimes in the questions they will mention the units, sometimes they won't mention, but whenever you are having the power, so obviously when they mention average power, obviously the units are watts, right? So the answer for this question is 2. I hope it is clear for everyone, right? So now let us move on to the next question. So all of you give it a try. This is a very interesting question. I hope all of you can solve this question. This is a direct question based on delta modulator. Yeah, this is the direct question related to the delta modulator. In this question, they are asking with respect to slope overload distortion, right? So you're having, they have given the information regarding the sinusoidal message signal, which is having 4 kHz frequency and which is having the corresponding amplitude as 4 volts, and they have given this particular message signal as a input to delta modulator operating at a sampling rate. They have given the sampling frequency 32 kHz. They are asking the minimum step size. Minimum step size they are asking required to avoid slope overload distortion or slope overload noise in the delta modulator. They are asking the final answer. You can round off to the 2 decimal places. Okay. So in general, the slope overload distortion occurs because you are considering the delta value very small when compared to the optimum value, right? Now if you want to overcome that problem, you have to increase the step size, right? So that means with this understanding, you can write the relation regarding the condition to avoid the slope overload distortion. The condition to avoid slope overload distortion or slope overload noise. To avoid slope overload noise is delta by Ts greater than or equal to AM 2 pi FM. Whenever you are having the message signal either sine or cos, that time you will get dm of t by dt value, modulus value or magnitude, you will get this value AM 2 pi FM. Okay. So here 1 by Ts we can write as sampling frequency greater than or equal to AM 2 pi FM. Now from here you can write delta greater than or equal to Fs I am bringing here, it will come into the denominator, AM 2 pi FM divided by Fs. So delta value should be greater than or equal to AM 2 pi FM into Fs. Now you can substitute here whatever the values required which are given in the question, directly you can substitute. So from here you will get delta value greater than or equal to AM is the amplitude of the message signal, that is nothing but 4. Next 2 pi FM. FM is nothing but the frequency of the message signal, which is nothing but 4 kHz divided by sampling frequency 32 kHz, right? So here kk will get cancelled, 4 8 times, 4 2 times, 2 1 time. So finally here you are getting pi. I hope all of you know the value of pi. Pi is nothing but 22 by 7, which is nothing but 3.14. So that means delta value should be greater than or equal to 3.14 volts. So here you can choose delta value, any value starting from 3.14 and even greater than 3.14, any value you can consider. For all those values, you can avoid the slope overload distortion or slope overload noise. Now they are asking the minimum step size in order to avoid the slope overload noise. So that means when you consider equality, that time you are going to get minimum, right? When you are considering greater than, that time you are getting all the higher values, right? So delta min step size minimum step size is equal to 3.14 volts. So the answer for this question is 3.14. I hope it is clear, right? So now let us see the last question, which is asked in GATE EC 2021 for 2 marks. This is a very interesting question. All of you give a try. This is the last question. All of you give a try. This is a very interesting question which is asked in GATE EC 2021 for 2 marks. First, let us read the question. You are having a message signal which is having the peak to peak value they have mentioned 2 volts, and the corresponding root mean square value, so that means RMS value they have given 0.1 volt, and bandwidth of the message signal they have given 5 kHz, and then it is sampled. After that, it is given to pulse code modulation PCM system that uses uniform quantizer. The PCM output is transmitted over a channel that can support a maximum transmission rate of 50 kbps. Assuming that the quantization error is uniformly distributed, the maximum signal to quantization noise ratio, that can be obtained by the PCM system is dash. What is the answer you are going to get? You have to round off to the 2 decimal places. This is a very interesting question. This is a direct question regarding PCM, but when you look at the question, the wording here, some values they have given directly, but some values here in this particular question very interesting. Okay, whatever the notation they have used, accordingly we have to construct. That is the reason I have mentioned this question is very interesting, right? So here in this question, you have to calculate the maximum signal to quantization noise ratio. Okay, first of all, write the signal to quantization noise ratio formula. After that, let us find out the maximum value, right? So first of all, note down the signal to quantization noise ratio formula. Signal to quantization noise ratio, which is nothing but the ratio of signal power and quantization noise power. Ratio of signal power and quantization noise power. Ratio of signal power and quantization noise power. So here we have to calculate the signal power. So regarding the message signal, they have given the root mean square value. So once if you know the root mean square, if you perform square of that one, that is nothing but your signal power, right? So signal power is nothing but the square of RMS value. VRMS square, in simple words you can say VRMS square, okay, right. Regarding quantization noise power, so which is nothing but delta square by 12. So here 12 will go into the numerator. So VRMS value they have given 0.1 volt whole square divided by delta is nothing but step size. So step size is nothing but peak to peak voltage divided by the number of levels, and then you are having whole square. So 12 into 0.1 whole square is nothing but 0.01 divided by peak to peak voltage they have given 2 volts. Divided by number of quantization levels is nothing but 2 power n. So from here what you will get, 12 into 0.01 you can write as 0.12 divided by 2 square is nothing but 4. This 2 power n whole square is nothing but 2 power 2n, and this term will come into the numerator, right? So from here you can write, and 4 here 0.03 times 0.03 into 2 power 2n. So you can assume this is the equation 1. So regarding SQNR, we got the equation like 0.03 into 2 power 2n, right? Once if you know the n value, if you substitute n value, from there you will get the SQNR. But in this question, whether they have given number of bits directly in the question anywhere? Just look at the question. Do we have number of bits directly in the question? No. we don't have, but we have to find out the number of bits. Once if you are able to find out number of bits, after that you can easily proceed further, right? So here you just read this question from here. The PCM output is transmitted over a channel. That channel can support a maximum transmission rate of 50 kbps. Now after reading this sentence, can you tell this 50 kbps is nothing but which parameter with respect to channel? Yes, very good. With respect to channel, this 50 kbps is nothing but the channel capacity. See here what they have mentioned, this channel can support maximum transmission rate of 50 kbps, right? So that means the capacity of this particular channel is nothing but 50 kbps. So they have given channel capacity. They have given channel capacity C equal to 50 kbps. Channel capacity they have given 50 kbps. Okay. So what is the relation between bit rate and channel capacity? Whether it is less than or equal to or greater than or equal to. In general, what is the relation between bit rate and channel capacity? Yes, obviously the bit rate should be less than or equal to channel capacity, right? So if the bit rate is more when compared to channel capacity, so you cannot transmit because you are having the capacity of the channel is limited, but you are sending the bits at fast rate, right? So if you are sending the bits at the rate in such a way that this channel can support, okay, so that is the reason we have to consider RB always less than or equal to channel capacity. So in the PCM, bit rate is nothing but N into Fs, N into Fs. So this value should be less than or equal to 50 kbps. K I am writing it as 10 power 3. 10 power 3. Now in the question, they haven't mentioned anything about N, they haven't mentioned anything about Fs. But in general, regarding Fs, we will consider, so the sampling frequency will consider it should be greater than or equal to 2 times maximum frequency of the message signal, so that at the receiver, when you are extracting the analog information from the sample signal, you can extract the original information without losing any information, right? So if you are not maintaining this relation, you may lose some part of the information, right? So this is the relation you are having regarding the sampling frequency. Any value you can consider greater than or equal to 2 times Fm. So now when you look at this particular relation, so at least can you guess what value we can choose for Fs? Yes, here this overall value should be less than or equal to this one. So that means better you can consider the minimum value for the sampling frequency, right? I hope you are getting the clarity. So that means Fs minimum is equal to 2 times Fm. So that value I am considering now. So N into Fs minimum I am considering. So that is less than or equal to 50 into 10 power 3. 50 into 10 power 3. So Fs minimum is nothing but 2 times Fm. 2 times Fm. So in the question, Fm they have given as 5 kHz. Bandwidth they have mentioned. See, for the message signal or modulating signal, baseband signal or band limited signal, all are same. So regarding bandwidth or maximum frequency of the signal, all are same. So bandwidth they have mentioned 5 kHz. So that means maximum frequency also same, 5 kHz. 5 kHz. Okay. So here 2 into 5, 10. Here 1k, 10 power 3. Both will get cancelled. 2 into 5 is 10. So 10 will get cancelled. 10 and 0 will get cancelled. So from here, you are getting N is less than or equal to 5. Now tell me, regarding Fs, we have chosen minimum value. Now tell me regarding N, what value we have to consider? So just look at the last two lines. Here we are supposed to calculate maximum signal to quantization noise ratio. Just read this one word. Okay, maximum signal to quantization noise ratio. With this you will get the clarity. Whether we have to consider n value minimum or n value maximum in order to satisfy this relation. So just by observing this relation, n value you can consider 1, 2, 3, 4, 5. You are getting 5 possible values. So among those 5, which value we have to consider? Any guess? See, here the relation between number of bits and number of levels you are having like this, L equal 2 power n. If you have considered only 1 bit, that means you are getting quantization levels are 2 only. If you have considered 2 bits, number of quantization levels are 4. If you have considered 3 bits, number of quantization levels are 8. Similarly, for 4 bit, number of quantization levels are 16. For 5 bits, number of quantization levels you are going to get 32. So now just observe the number of quantization levels. If you are increasing the number of quantization levels, the quantization error is getting minimized. If you are getting minimum quantization error, obviously the quantization noise power becoming less. If the denominator term is getting less, overall term is going to get maximum. So now you can, so whether we have to consider minimum value or maximum value, you have to be very smart. That is the reason I have mentioned this question is very interesting, right? I hope all of you got the clarity why I have told multiple times this question is very interesting. Okay, if you want, you can put the star mark for this question. This is a very excellent question. Okay, this is an excellent question. You can mention this is a very good question. You can put the star marks for this question. I am putting 5-star rating. This is an excellent question, right? Okay, so here we have to consider n max, the maximum value of n we have to consider. The maximum value of n is 5. 5 bits we have to consider. I hope you are getting the clarity why we are choosing n value as 5. Why we are considering regarding the number of bits as maximum. Okay, right. So we got signal to quantization noise ratio like this. So even from here also you will get the clarity. Just by observing this equation also you will get the clarity whether we have to consider n value minimum or maximum. You can observe here 0.03 anyway constant. Here n you are having in the power of 2. Okay, if you are considering maximum n value, obviously you are going to get this value maximum. So what are the relation here you got? In order to satisfy that relation, whichever n value you are going to get maximum, that n value you can consider like that. Okay, right. So SQNR max, signal to quantization noise ratio maximum, is equal to 0.03 into 2 power 2 times n. Now in the place of n I am considering n max, right? So 0.03 I am keeping as it is, or we can write it as 3 by 100 into 2 power 2 into n max is nothing but 5. 2 power 2 into 5. 2 into 5 is nothing but 10. So you are getting 3 by 100 into 2 power 10. I hope all of you know this formula, this value, standard value. 2 power 10 is nothing but 1024. Okay. So here when you multiply these two numbers, you will get 7203 divided by 100. So that means you are going to get 30.72. So the answer for this question is 30.72. Okay. So this is a very interesting question. So in this particular session, we have dedicatedly focused on the selected GATE questions of which are asked in the GATE 2021. Okay. So all these questions are related to EC branch. Whatever the concepts here we have discussed, these concepts and questions will be helpful for both EC branch and instrumentation branch. So whoever missed the last 2 sessions, kindly watch those lectures. It is available in the playlist, okay, in our YouTube channel, in the IMS GATE Academy YouTube channel. In the YouTube channel, just type IMS GATE Academy. So there you can see the various playlists. So regarding GATE PYQ series communication system subject, you will be having the playlist. So in that you can watch the previous lectures, okay, if you have missed due to any reason. So this is the 3rd session. Similarly, we are going to have 2 more sessions in this month. Okay, so regarding that, you can see in the playlist, and okay, so on whichever date it is mentioned, you can kindly join, and all of you kindly subscribe our channel and click on the bell icon in order to get the instant notification. So right, so all of you kindly share this information with all of your friends and share this video links with all of your friends, so that they also, based on the possibility, will attend these sessions in live, and due to any reason if not possible, so they can watch these lectures in their free time also, right, whenever based upon their convenience, right. So all of you kindly subscribe our channel and try to attend the live sessions as many as possible, so that you will get maximum benefit from this series of sessions, right. So we'll meet you all in the next session. Thank you everyone.